Hello everybody, welcome to I call it the flame test lab, but it's kind of the emission spectra lab. And the whole idea of this lab is to understand that if you heat or energize an atom, it gains energy. And immediately after gaining that energy, because it doesn't want it, it lets it back away. And when energy kind of changes like that, it can transform. And in the case of atoms releasing their energy, it's usually released as light. And we can call those emission spectrum. And we're going to look at those in this lab and kind of see how different atoms emit energy differently. And later on, when we talk about where electrons are in the atoms, we'll come back to this idea of how where the electrons are determine how much energy can switch place with how many quanta of energy, and that determines the colors that are given off. And when you add all the colors together, like individual wavelengths of colors, you get a single color that our eyes perceive. All right? I can make myself a little bigger here so that you can see me a little better, but I don't want to take up too much of the screen here because I'm going to be showing you some of these colors. All right. So in this lab, we're going to start by looking at gases. And you can get these tubes, and they're called gas emission spectra. And when these tubes light up, you get a color like here. Now, what I want you to do for this part is kind of explain the colors that you see. Now, in this image that I got online from from where I bought my tubes from, you can see on hopefully it's on your right of the image, what the tube looks like when it's fully lit. And on the left are if I took this color on the right, if I took the color on the right and I separated out all of the individual wavelengths within it, you would get what you see on the left. That's kind of its spectrum is on the left, and on the right is the color that you see. And what I want you to do is basically describe these colors that you're seeing. And more importantly is the color that you see on the right, the actual spectra. Now, if you ever, I do have a helium laser. I had a helium emission spectrum tube, so I don't actually have this to show to you though because it literally just broke when I was trying to record this lab, so I don't have it on video. So I can only show you the image here, but this is kind of what it looks like. It's a little bit so either it's a little bit overexposed. It's normally a little bit, it's kind of an orange to a red orange is usually the color that you see. And you can see on the left that there is a red and a kind of an orangey yellow there and a few blues and a purple that come out when you separate all of these colors. So that's helium. And that's literally all we're doing is we're describing colors in this lab. And you can pause this video whenever you need in order to kind of write these colors down. So next we're going to go to argon. So this is a video of an argon emission tube, right? And you can see kind of the colors there. And I'm going to turn the light off, and right there, see the color that's being, it's kind of going in and out of focus, but if you see the color that's kind of being transmitted onto the black in the back of it, and I'm actually going to kind of pause it right about there where I have a good in focus picture. You know, because in these videos and in these still images, it's much easier in person, but if you kind of look at the color that's being projected onto the black, you can kind of get an idea. And I don't want to tell you the color because the whole idea is for you to describe the color that you see. So you can kind of see it right there. And don't look at the top and bottom. Look at the line of light. So basically what's happening is a tube filled with gas is being electrified, and that's giving off this color, similar to what you would know as a neon light, right? So they're kind of right about there as the camera refocuses, you can see kind of the color that you want, right? Now you can pause this video wherever you need to kind of write down argon. And here is an image. It's actually a pretty good image of argon. Okay, so that's argon. Now we go to mercury. And here I'm gonna pause this right away if I can get that to stop. All right, because it came up really nicely. So this is mercury vapor in a tube, and it gives a really nice light. I'm not going to tell you what the color is, but you can see the spectrum there. You can also see the individual image. I can make that a little bigger here so that you can see it better. That separates all of the colors out. And when you put all of these individual colors together, you get the emission spectrum that you see. All right, so that's mercury. Now we go to xenon. Okay. Now this one, I can only find this image here that I kind of blew up, but I'm going to let this go for a little while and try to find a good spot to pause this so that I can show you kind of what it looks like. It never really wanted to focus there, but right about, I mean, even though that's out of focus, kind of the color you can see is really good that's coming out right about there. And you might actually be able to see it pretty well right here. And actually, if you look at the top and the bottom of the emission spectrum, you get a really good indicator of what the color of this gas is when it's electrified. So that's xenon. Now we have the next one is krypton. And why am I putting this white piece of paper behind there? If you look at the emission spectra, so I got a different, because we're actually going to look at the color spectrum through gratings in class, but I couldn't really get a good image of that through my camera because I couldn't get it aligned right so that you would get the kind of the rainbow here. But more importantly to show here is that krypton, and there are like 36 electrons in krypton, so there are a lot of different energy levels that the electrons have, and they can absorb a lot of different energies and give off a lot of different energies, and you'll see that you get just about every color. And you'll notice here, and this is why I put the white piece of cloth behind it too, is that when you put them all together, it's kind of close to white, maybe with a little hint of blue or purple, but it's really, this one I'll just kind of tell you, it's really close to a nice white light that you get from krypton. And these are basically what you get from a neon light. And oddly enough, I don't have a neon one of these yet. I've only, I had enough money for 5 of them, and I already broke 1 of them. So hopefully I'll get some more soon. So I'll pause there if you need to. You can go back. But those are the gas emission spectra that you need to describe. Now you can also do the same thing where you can take a salt crystal of an atom, or not even just the salt crystals, you can also dissolve it in water in a high concentration, put that onto like a nichrome wire, or in this case I used wooden splints, and you can burn them in a Bunsen burner and you can kind of tell what the color is. Now the only bad thing is if it's colorless, you won't see it, because some things do burn with kind of a colorless color, but if it is the same color as the Bunsen burner, you really can't get that. And so if you notice right here, I've got the Bunsen burner going, right? So I'm getting ready to put in the first compound into this. So if the emissions from these crystals and liquid solutions as I put them into the flame are the same color as the flame, and this is basically, you know, the Bunsen burner flame has this kind of bluish tint to it, then you're not going to be able to see it. So I didn't pick combinations that would give you the same color. But the first one that I have here is lithium chloride. So lithium chloride, so I got to wait for all the liquid to burn off, and then we'll get it here, and I'll find a good spot where you can really see the colors coming off of it, right about there. So the water has boiled off, and I'm holding a splint in the flame, and I'm pausing the video here, and you can see it. And this actually is kind of nice because you can pause it online and you can really see the color that this forms. So that's the color that you're trying to describe for this one. And you can go back and play it back again. Actually, kind of got a nice little bright one there at the end too, it looked like. Okay, so that was lithium chloride. Lithium chloride. Lithium chloride. Which is the first one. After this, we went to sodium chloride. So here's our sodium chloride. And let me kind of go back through that and play it slowly. And I think I have a really good one in the middle here, I think is where I had one. I'm trying to pause it right there. So you can kind of see the flame coming off of this. I'll let it play normal speed. Once more. Right. So that's the color of sodium chloride. Now we're going to go to potassium chloride. And remember, you can always rewind or pause the video if you need to.
Potassium chloride.
So here's potassium, KCl. And this one, if I remember right, there was a good spot in the middle that really showed the color of this one. Because this one was actually really hard for me to get a good color because that's the splint actually catching on fire in this one, and it happened every time. But I know there was one spot in this video, I'm going to try to pause it, where you can kind of see it right here, because you see the blue flame, but do you see the kind of purple coming up around the flame before the splint catches on fire? That's the color of the potassium chloride. Here I got a better one here. Try and play this and get it to pause at a good point. I don't know if you can sort of see that purple coming up from the flame right before the splint catches on fire. So potassium chloride normally gives you a little bit of a purple. I don't know what else to tell you there. So then we went to strontium chloride, SrCl2, right? So now we're in the lithium, sodium, and potassium are monovalent, so they just form +1 cations. But now we're going to deal with the +2 cations. And that's important because I want you to tell me what the metal ion is. So we're at the +2 cations now with strontium chloride.
Strontium chloride.
Okay, so this is strontium chloride. And I may not even need to pause this one because I get a really good reaction here. Right about there, you can kind of get a good color of it. Good images. It almost gets washed out. So look at the tip of the flame. If you look just at kind of like the tip, because it's getting kind of washed out and it's appearing more white than it's not really white. Look at the color towards the top there. That's the color that we're looking for strontium chloride. Then we go to calcium chloride. Keep going
calcium
here.
Chloride.
Solutions. So calcium chloride, I'll be straight up with you, it's very similar to strontium chloride, but it has usually a little more towards the orange side, and strontium chloride is usually a little bit towards the red side. So this is calcium chloride. You'll see I got the splint on fire there, but there's a good picture. See how I said this one's usually a little bit more on the orange side, and strontium you might have seen a little bit more red in it. So there's a good image of calcium chloride. I'll let this play through to see if there's a better point where I get a better color of it. I added a little bit more. Splint caught on fire on me again, which happens. Yeah, so it's just so bright that where I had it before, right about there, is the kind of the best image that you're going to get for calcium chloride. Now we go to some I think pretty ones. Barium chloride. Barium chloride has let me make this a little bigger. And it's getting a little bit washed out because it just looks like it's white. So I'm going to try and find a good place to pause the video so that you'll get the color. And I think I said there was a good thing somewhere in the middle here. Yeah, right about there. You see that color to the left right there? I'm going to play at normal speed through there and then I'll rewind it. Oh yeah, I got a great color reaction there. I'll just keep replaying that right through there. That's barium chloride. Okay. Now our last one is copper 2 chloride. Now I also ask you on the lab to tell me the color in solution, and I can tell you that all of these are clear in solution except for copper 2 chloride, which has this color. Now this, at least on my screen, it's coming across as a little more blue than it actually is. It's a very, very pronounced teal color. Like if you think of teal, that's what it is. It's looking a little bit too, it's a little bit too blue on my camera. There's good light right there. Right there seems a pretty good indicator of kind of the teal color that this gives you. So this is the copper chloride, okay? And that'll be our last flame
Copper 2
test
chloride.
here we'll look at. And I get a really good reaction again. Kind of see that color going through. Rewind it, play that again. So this is our copper 2 chloride. So pause this video as you need to kind of explore and tell me what those colors are. But that takes us to the last part, which is an unknown. Based just on the color that you see from this, can you tell me what this one
Unknown.
is? This is your unknown. And I can tell you that the solution was clear. I'm going to do it again there. You get a really nice bright flame. Okay. Now one of our solutions had a kind of a bright flame like that, and you can go back and look again, but try to identify what this is. Now, more importantly is number one's, say, where do I say, I don't know if I put that there, but under the unknown where it says color of the flame, I can tell you the solution was clear. Under the color of the flame, what I'm more interested in, because the idea is, can you tell me what the compound and the metal are? So you just describe this color. That's what you'll put under color of the flame. Color of the solution is clear. And based upon those two, going up to the above solutions, can you tell me what you think this metal ion and the compound is? And if you have to go back and look at the videos, you can. Okay? But this is the color that you want to find something else that burns with this color from these choices. And then there are a few questions. Questions are like, let me pause the unknown kind of in a good spot where you get a good color. Right. What is an ion? You should know that. That's question number one. Question number two, why do different elements give off different colors of light when they are heated? If you don't remember what I said at the beginning, you can just read the beginning of your lab guide, right? The next question, if you were an astronomer studying the light given off by a star, how could you use the information observed in this lab? So think about that. And you can read, once again, you can read the top there and kind of come up with ideas. And the last question is, what might be another practical application of metal-containing compounds that create different colors of light while burning? And just off the top of my head, I can think of about 20. So just think about ways that we create colors through burning. Like, something should come to your mind pretty quickly. All right? And if not, just think about it for a little while. Look it up online, whatever. Just try to think of applications of this kind of idea. Okay? So that's it for this lab. I hope you enjoyed the colors. I'm sorry that you couldn't be in lab, so if you're watching this, that means that you couldn't be here the day that we did it and get to see all of the nice bright colors. It's a lot more fun in person. Or you were here and you had to come back to see the colors again to help finish up the lab. And if there are any questions, as always, just let me know.